Hello, hi friends, myself Depavath Chandu Naik. In this presentation, I am going to discuss about addressing modes of 8085. So, let me define what does mean by addressing modes. To perform any operation, we have to give the corresponding instruction to the microprocessor. In each instruction, programmer has to specify three things. First one, operation to be performed. Second one, address of source of data. And third one, address of destination of result. The method by which the address of source of data or the address of destination of result is given in the instruction is known as addressing modes. The term addressing modes refers to the way in which operand of the instruction specified. The addressing modes are the different ways by which the microprocessor specifies the operand in the instruction. Addressing modes are an aspect of a instruction set architecture in the most central processing unit designs. And the various addressing modes that are defined in given instruction set architecture defines basically the how the machine language instruction in that architecture identifies the operand of each instruction, as well as an addressing mode specifically how to calculate the effective memory address of an operand by using information in the register or constant content in the machine instruction or elsewhere. In basic computer programming, the addressing modes are interest to those who write in assembly languages and to compiler writers. Based upon address of source and address of destination, 8085 microprocessor supports the following addressing modes. Those are immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, and implied addressing mode. Let us discuss one by one. So, what does mean by implied addressing mode? In this implied addressing mode, data is specified in the instruction itself. So, let me discuss with an example. For example, we have an instruction like MVI A35H. It means move immediately the value of 35 into the accumulator, right? And second one, LXAB 4000H. It means move immediately the value 4000 into the register pair BC. We know we have different types of register pairs, right? In those, BC is an register, one of register pair. And now it is second one, register addressing mode. In this register addressing mode, the data is specified in the registers. For example, if you take instruction like move BC, it means move the content of C register into the B register. And second example, INRP, that means increment the content of B register. Increment, that means we are adding +1 to the register B. And the advantage of this addressing mode is a microprocessor requires only one machine cycle to fetch the instruction. And we have one disadvantage also, like operand cannot be easily identified in this register addressing mode. Now the direct addressing mode. In this direct addressing mode, the address of operand is specified in the instruction itself. If we take an example LDA 2000H, it means load the accumulator with the content of location 2000. Here we are specifying the location. And second example, STA 2000H, it means store the content of accumulator at the location 2000. Same, here we are specifying the location. And some advantages are like the programmer can identify the address of the operand very easily because we are specifying the address in the instruction itself. And disadvantages like we need 3 byte instruction, so it needs 3 fetch cycle, so it's take more time, so it's slow down. Now the fourth addressing mode, that is indirect addressing mode. In this indirect addressing mode, the address of operand is specified in the register. Hence, instruction indirectly points to the operand. Even the memory pointer M can be used as it is pointed by the HL register pair. For example, if you take stacks B, STAX B, that means store the content of accumulator at the location. That location is pointed by memory pointer M. That memory point M is referred by BC pair. Indirectly, the accumulator is pointed by BC pair. And second example, increment M, that means increment the content of location pointed by HL pair, because M means memory pointer, right? And here some advantages. The advantages are the address of the operand is not fixed and hence can be used in the loop. The size of the instruction is small as compared to the direct addressing mode. And here some disadvantages are it requires initialization of register pair. Hence it requires at least one more instruction to initialize the process. Now the last addressing mode, that is implied addressing mode. In this implied addressing mode, operand is implied in the instruction. This instruction will work only on the implied operand, not on the other operand. For example, STC, that means set the carry flag in the flag register, right? And second one, CMC, that means complement the carry flag in the flag register. And here some advantages and disadvantages are, the advantages is instruction are generally only 1 byte. It is a single byte instruction, so it requires very small memory. It is beneficial for any microprocessor, and it makes very faster. And the disadvantages is programmer cannot easily identify the value of operand, because operand is in the instruction in implied form, so it is very complicated to identify the value of operand. So finally, in this presentation I have discussed what does mean by addressing modes, the various addressing modes that supports 8085 microprocessor and their characteristics, and the advantages and disadvantages of these addressing modes. Thank you.